welcome. This video is going to be about waves. So last week you dipped into this a little bit, but today we're going to take it a little bit farther. Waves are extremely important for understanding the world around you. What they are is they are a way of moving energy from one place to another. They are energy on the move. So they can come in all kinds of varieties. Sound waves, electromagnetic waves, heat waves, all of this stuff is a wave of some sort. So to understand what these are, you kind of have to understand what a wave is and kind of really analyze a wave and figure out its characteristics. And then you can apply that to different situations. So let's look a little closer. And I drew a diagram to help us out. Okay, so here we've got a wave. And it starts here and goes across the page this direction. There's a couple things that we can learn about this wave. So let me get a pen here. So there's a couple things we can measure. First things first is the distance, or how long this wave is. So the distance from the start of one hump to the end of one valley. So right here, the next hump is going to start. So from here all the way over to here is what's called the wavelength. So you have different wavelengths of light and sound, and they're different lengths of the wave, which makes sense. So this is the technical name for this is the crest, and this is the trough. So this is the crest here and the trough here, and together they form one full wavelength. So if you have a wave that has a shorter wavelength, that wave actually has more energy than a wave with a longer wavelength. Because the wave that has a longer wavelength is moving much slower. So if you would have a single point and the wave is passing by that single point, it would be like a boat sitting in the middle of a lake as a wave goes past. And if it's a really long wave, then if you watch the boat, it would kind of go like this. It would go like up really slowly and then back down really slowly as this slow wave with a long wavelength goes past. But if we have a lot of short wavelengths, then it's going to be bumping up and down and sloshing and almost capsizing as these short, quick, fast waves go past. So if you have a shorter wavelength, you most likely have a higher amount of energy being transferred in that wave. Okay, what else? We got more. Okay, so you can measure this, but you can also measure from here, from the bottom of a trough all the way up to the top of a crest. That is called the amplitude of the wave. So you measure from the very top to the very bottom, and that's the amplitude. If you increase the amplitude, make the wave bigger, it also holds more energy. So the taller a wave is, the more energy it is carrying. And we're going to be learning about sound waves and how amplitude and wavelength factor into sound this week, so pay attention to that. A third thing is the frequency. So, okay, this is cool, but how do we know how fast this wave is traveling? Because different waves travel different speeds. So the frequency is a measure of how quickly one wavelength goes past. So if I measure, okay, from here to here, let's say it took 0.1 seconds. So that is one wavelength per 1/10 of a second. So we could call that is the frequency of this wave. The measure of like the standard measurement for frequency is the hertz, H-E-R-T-Z. And a hertz is 1 cycle per second. So how many cycles or wavelengths are passing by in 1 second? So in the video we watched last week with the sand on top of that metal plate, you could see the hertz, the Hz along the side, and that was telling you, okay, this is like 1,000 hertz, 1,000 cycles per second, incredibly fast. So the three things we can measure about waves is the wavelength, the amplitude, and the frequency, the speed it's passing by. And they can each tell us interesting things about the wave itself. So that's all we have for now. I'll see you later.